What's up, Internet? Welcome to Chyld Studios. My name is Chyld. Today I'm going to be talking about currying and partial application using Ramda. So what we're going to be using the Ramda JavaScript library so I can illustrate some functional programming concepts, currying, as I mentioned, and partial application. So these can be slightly complicated concepts. So the examples will start out simple, not too complicated, and then we'll progress slightly to slightly more sophisticated examples, but nothing too bad. This is really just an introductory video into currying and partial application. Okay, so I'm gonna go ahead and get started. So here I have a terminal window, and we're going to be doing this. This is in JavaScript, so I'm going to be doing this in Node. I currently have running Node 7.5. So I'm going to go ahead. Sorry, I was going to clean those up before I started my. Before I started this video. So we're going to create a tiny little node, a tiny little node application. So I'm just going to do npm init and run through these. Nothing really that crazy. Create a package.json file, and I'm going to say touch index.js. Here's the file I'm going to use, and then I'm going to npm install Ramda. Save. Yes. Now I have another video that I did a couple days ago on Ramda. So if you want to see that, and then there's some functional. Well, it's a video on Ramda and functional programming concepts using JavaScript. So that video was taken a few days ago. Okay, so this looks pretty good. I'm going to go ahead and open up my editor. I'm using VS Code here, and yes. Okay. So the first thing I want to talk about is currying. Currying, and I'll show the website for this. Currying basically takes a function that takes multiple parameters and creates a function. Basically creates a function that can take one parameter at a time. So that's a little bit complicated to say. So it's best really to just describe it. But anyway, here's the docs on it if you want to go back later and read more about it. Well, actually, if I were to just continue on just really quickly on this site. If you see this G123 right here, basically that's the function G, and it takes three arguments, 1, 2, 3. But after it was curried, you can see up here it turns it into a function that you can call basically 3 separate times. You call it once, you give it 1 parameter, and then you can call it again with a second parameter, and then you can finally call it 3 times. So instead of calling it once with all the arguments, you can call it. You can give it an argument at a time. So that's sort of the example on the website. Once again, this can be a little bit complicated to understand like what it's actually doing. So I'm going to give an example. So I like to start off with something simple like add. So I've already installed Ramda, so there it is. And because I have that node module, I can say const r equals Ramda like that, and that brings in that node module, and now I can use it. So the first demo I want to show is something simple, addition. So let's say I were to make a function. Let's say I called it add. And I want this function to take in two values, x and y. And you can see here I'm using JavaScript ES6 syntax. So here's a function, and this is the arrow syntax. And it's taking in 2 values, and you just add. Of course, you're going to return the sum. When you're using ES6, you don't actually have to say return. If you're not doing any squigglies or curly braces, you can just give the expression x plus y. So here the return keyword is actually not necessary. So here's a function that can add. Great. Now if you want to call it, obviously you just say add and give it 2 values, and that's fine. But what if you wanted to take this add function and make another function out of it that always added 2? So whatever value you gave it, it just added 2 to whatever that number was. Well, if you want to do something like that, you could say, well, in order to do so we're going over currying now. So currying, like I said, what that does, it takes a function and it allows you to basically break that function up into, or break the arguments up into separate arguments per function. Let me show you. So here I have add, and it has 2 inputs, right? It has x and y. I can curry this by saying const. Let's call this add2. And I'm going to use the curry function in R, like this, and I'm going to give this a function name. So it says give it the name of a function. So add. So add, I can just, well, that's probably not appropriate since I call this const here. Let's just call this let here. Therefore, I can change the function definition. Like, right? If you use const, then you can't change it because const means it's constant. So add means so here's the function add, and then basically what I'm doing is all this line 4 is doing is just making the function curryable. So you can call it one argument at a time. So right now this add is sort of the same thing. It's basically just a function that takes 2 arguments, except now you can call them individually. Let me give you an example. So I'm going to use the const keyword now because I'm not going to change this other one. I'm going to call it add2. So what I want to do is I want to call the add2 is I'm going to call this function add, the one on line 4, and I'm going to give it one value, 2. Okay, so this function add is curried. So that means you can call it with just, see how on line 3 this function takes 2 parameters, but I'm just giving it just 1 argument, right? So how can I give this add just 1 argument? Well, the reason you can do that is because add right here is now a curried function, so you can call it with just 1 parameter. So to prove that add2 is actually a function, I can say like that, and then like that. And you can see right here it says add2 is a function, right? So that lets you know that, oh, it's actually not, if this were not curried, if you were just calling add before with just 2, of course, JavaScript, you can, the 2 would have went into the x, and then null or undefined would have went into the y, and then that would have been 2 plus undefined, right? And that would have been like not a number. But this actually works. This actually works because it actually is not giving you back null or undefined. It's giving you back actually another function. Okay, so what can you do with this add2 function? Well, you can now call it with a value. So let's say you wanted to add 2 to the number 10. Okay, add 2 plus. I'm just going to put this in here just to make it look more obvious. And you can see right here, add 2 of 10 is 12. So this means if you add 2 to 10, you'll get 12. And now you can use this function as many times as you want, right? You can say add 2 to 20 to 30, right? And so now, anytime you use this function add 2, it'll obviously just add 2 to the original to that value. So this is what's called declarative. Declarative means it's obvious what's happening. It means you're adding 2 to 10, you're adding 2 to 20, you're adding 2 to 30. So that's the whole concept behind functional programming. You sort of state your intention, and my intention is to add 2 to any of these values. But the only way you can do that is if you curried your original function. So add, the original add, was just a generic function that took in two values. But then using currying, I was able to make this more specific function called add2 that I can use in more specific cases. So that's an example of currying. Currying, once again, just takes a function and it takes a function with multiple arguments and turns it into a function that you can call it with one argument. It'll give you another function back. You give another argument, it'll give you another function back. You give another argument, it'll give you a function back until you finally give it the last argument. Once you give it the last argument, then it'll actually execute and give you an actual value. So that's an example of currying. Now let me give an example of partial application. Now partial application is kind of like currying, except you provide some value. So partial application just means when you apply a function, that means you're calling it, and to partially apply it, that means you're calling a function with and you're omitting a few arguments. So if the function takes 3 parameters and you give it 1 argument or you give it 2 arguments, that's partially applying it because you're only partially satisfying its contract. So once again, I think it'd be useful to just show partial application using the same add function. So let's say I wanted to add 10 to some values. Well, okay. Well, actually that would be hard because add is actually already curried. So I want to show this with a function that's not curried. So let me do this with a multiply function. So I'm going to say const mul for multiply is equal to x, y, and then x times y. So obviously similar to the add function, except we're just doing multiplication. So if I were to partially apply this, let's say I were to create a new function called mul2, which means just multiply by 2. So whatever value you give it, it will give you, it'll just multiply by 2. So if I were to give you an odd value, let's say 3, it'll give you 6, or give you 6, it'll give you 12. So basically this you could think of this function as taking in any integer and making it even. So how can I do that using partial application? Well, I can say r.partial. And how partial works is you have to give it the name of a function basically that you want to curry. And I want to curry the multiple function, but then I want to actually go ahead and give it the first value. So instead of currying it and then giving it a value like we did up here, I can actually curry it and also go ahead and give it the first value. So you have to do this in an array because it's an array of values, and those are the values that get injected into these parameters here. So because I only want one value to go into the x parameter, I want it to be 2. So you use an array because that's the array of values. If you put 2 values in here, one would go into the x, one would go into y. But you wouldn't do that because that's not partial application. That is just applying a function. So partial means you're only giving part of the arguments. You're not giving all of them. So now that I have that, if I said mul2 times 30, let's do 50. Right? That should be 100. So multiply 2 times 50 is 100, add 2 to 30. So once again, you can see this is very declarative, right? It reads nice, your intentions are obvious, and it allows you to take generic functions or semi-generic functions like mul or add that are, as I mentioned, generic, and make them more specific. by using either currying or partial application. Currying, once again, just takes a function and currying, basically all you do is you just give it a function, and then it basically allows that function to be partially applied. Whereas partial goes ahead and curries it and it goes ahead and applies some values to it. So partial is actually well, they're both useful in different contexts. I'm not going to say you should use one or the other. I tend to use partial more often because it does a currying and a partial apply in one step instead of doing curry. But they're both useful. Now the documentation for partial is right here. I'll let you read that. I'll make sure these links are on the YouTube channel, so you can look for those. So this is pretty neat. This is just a basic overview. I want to show some more interesting examples of currying and partial application. Okay. I'm going to go over another example now using timers. So in JavaScript, there's a timer, there's a set timeout, and the timeout runs every so many milliseconds. Basically, every 1,000 milliseconds is obviously 1 second. But when you call the set timeout function, though, you don't really. If you're new to it, like you'll pass in a 3 or 5 thinking it's a second, but really it takes milliseconds. But what if you were to abstract those low-level details away? So I'm going to make a generic function. I'm going to call it timer, and it's going to be equal to I'm going to call it ticks per second and the count. So if I return ticks per second times count, yeah. So what that'll do is if there's 1,000 ticks per second, or basically in JavaScript 1,000 milliseconds times a count, say 5 seconds, then if you were to do that, then that's how long your timer would last for. But what I have here on line 16 is very generic. I want to make it more specific to JavaScript. So if I were to say, I want to define a second as, and I'm going to partially apply the timer function, and I'm going to give it 1,000 for the ticks. That basically means 1,000 goes in ticks per second. Timer is this function right here. I'm partially applying it, which means I'm only calling it one time. I'm calling it, and I'm calling this function timer. It's currying it, and it's giving it one value. So second here is basically the remainder. It's a continuation function, which means once I call second and I provide it the final value, then then it will call this. So basically second needs one more value. To prove this, if I were to say second 3, for example, this would be 3 theoretically times 1,000, which would be 3,000. And there it is, 3,000. So that looks good. What I can do now is actually use this in a set timeout context. And I could say set timeout, some function, timer being called, and I want to call this now after 3 seconds. So once again, this is very declarative, meaning I can look at this and go, oh, like anybody, even a new developer, should be able to look at it and go, oh, 3 seconds. That's 3 seconds. Versus if it said comma 15,235, you'd have to know specifically that's how JavaScript works. It's actually milliseconds. So let's run this, see what happens. So 1, 2, 3, and then there it is. The timer was called. So yes, so it works. So once again, I took a generic function timer, and by using currying and partial application, I was able to actually make a more specific version of a function. You can kind of think of this as like object orientation, where you have a generic base class like object or mammal, and then by using inheritance, you can create more specific versions like dog or Labrador, or very specific versions of animals. This is kind of the same thing where you take a generic or similar in content, meaning you take something generic like timer and you can make something specific out of it called second, or something like add and make something more specific at it called add to or mul2. Okay, so that was interesting. I'm going to give some more examples. What if you had an application where you were computing the tax for something? So someone wanted to, you had an e-commerce site, and someone wanted to figure out the total of something. Well, in each state, of course, it really is city-based, but we'll just be more generic here. In each state, let's say there's a state tax, and so depending on, let's say if you're Amazon or whatever, if someone wants to buy something, you have to take their total, whatever the total of their goods, and you have to apply the state tax to it in order to get their actual value. So you could probably start off with a generic function called like compute total. That would take in some tax percent, some like 3% or whatever, and then the amount that they want to purchase, their purchase amount, and then you could create a function that would take the amount. It would be the amount plus the tax percent times amount, like that. So here's a very simple algorithm. It just you pass in your amount and then you pass in your percent, and it basically gives you the total. So that's pretty neat. Once again, that's a generic function, but we can make it more specific to say I'm in California, so let's say I want to make it specific to California. I can say const, and then I could use Ramda's partial application, and I can say, well, I want you to use the compute total function, and I want you to partially apply some tax percentage. Let's just hypothetically say it's 9%. It's 9% tax. That's probably not too far from the actual truth. So I've created a new function called California. So if I wanted to know what is the total, or let's call this California price, California total, of $100. Let's say you were to purchase $100 of goods. Well, let's see what it says. So it says 190. No, I'm off by, I need another zero there. Yes, $109. So once again, you're taking something generic, a generic function like compute total, and you're making it specific. So if someone were to use this, they would say, oh, California total, or Texas total, or Nevada, or Montana, or Nebraska, whatever. And so you could create, hypothetically, you could create one function per state. I don't know necessarily if you would do that or not, but just the point here is you're taking something generic and you're making it more specific. You're declaring your intentions, which once again is the purpose of functional programming, to be declarative. One final thing. One final example. What if you want to do some unit conversion? You wanted to convert, let's say, some value to another value. Okay. So I'm going to create a function called a unit conversion. And what it's going to take is this is actually going to take a function this is the algorithm that we're going to use to convert one unit to another unit, and then the value I want to actually convert. Okay, so this is going to be basically all I'm going to do is going to say function and going to apply the value to it. So you pass in a function, and you apply the value to it. So that's super, right? That's super generic. But we can make it more specific. Let's say I wanted to convert Celsius to Fahrenheit. So I could say const so I have Celsius to Fahrenheit, and what I want to do is I want to call partial. I want to partially apply the unit conversion. I'm gonna make this bigger. And I'm going to give it the first value, right? So the first value is a function that takes in some value x, and it's going to return. Now this is a specific conversion here. So I'm taking x. X would be my Celsius, and so let's call it C for Celsius. And I would take my Celsius value times 1.8. Let's just do parentheses. Plus 32. Whoops, 32. So I've partially applied. I have a function here, and then I've given it one argument, which is the algorithm for computing Celsius into Fahrenheit. So now I took a generic function, unit conversion, and I made it specific by using partial application, creating this thing called Celsius to Fahrenheit. So now if I were to say, let's say, of course, 100 Celsius is 212 Fahrenheit. So it's always good when you're testing things out to like give values that you know what the answer is going to be. Also to write unit tests. Okay. So hypothetically, if this were correct, it would be 212, and there it is, 212. So that's it. I'm gonna have all this code up on gist on GitHub, so you'll be able to look for it on there. Once again, this talk was about functional programming in JavaScript using Ramda. It was about basically currying and partial application. Like I said, currying and partial application, they're similar. Currying allows something to be partially applied. You can't partially apply something unless it's curried. So these things actually kind of go together like peanut butter and jelly. So anyway, these are very powerful concepts in functional programming, and once again, they allow you to take something generic or less specific, functions that are generic or less specific, and make functions that are more specific to your actual context, your actual use case. Make the code that you're writing more obvious, more easy to read for yourself now, and for yourself in the future when you look at it later and you're like, what the hell did I write? And for other people looking at your code so they can figure out what's going on. Anyway, that's it. I'm going to be doing more videos on functional programming and JavaScript. Anyway, hope you liked it, and thank you.